as we travel again. So we use this, in-house mic. I don't like carrying the big microphone across country. It's easy to bend the prongs on one of the ends, and the cord gets once you break a wire in a cord, you're done. Time to go get a new cord. You're looking at Oulu neutron monitor, okay? And if you notice on the solar cycles, the solar maximums are signified by a dip in the neutrons. And then the solar minimums are highlighted by a spike in the neutrons. Neutrons are highly radioactive, they decay rapidly, and they're subatomic particles, and they come about through particle collision. The particle collision usually happens in the magnetosphere, where particles are accelerated and funneled into a tight area. The reason that we got more particles during solar minimums instead of solar maximum was actually a theory, and it was a reason. It was an excuse to justify how we got more particles when the sun was weaker, and we got less particles when the sun got stronger. And we have to come to the sad fact that neutrons are created by our second sun. And they're absolute proof that there's a second sun and a second source of particles. And solar minimum lets them in, solar maximum pushes them out. Proof we have a binary twin. And if that binary twin star got closer and closer, you would see a lot of interactions and radiation being produced in the corona of the sun. And when you look at the total solar irradiance, and remember, there's some irradiance values that have gone down, and some have gone up, and some have gone way up. But you can look at the trend in 2012 and say, well, gee, if this trend continues, because 1 watt per meter squared is 74 trillion additional watts that the Earth has to deal with. That's just an increase in 74 trillion. That's an increase in the background that this Earth is already dealing with. You could look at this graph and say, wow, this is going to heat our oceans. This is going to create droughts. This is going to create extreme weather. This is going to melt ice. And when it does snow, it's going to melt the snow quicker, and we're going to have greater floods. And the wind speeds on our storm are going to get worse, because the hotter the atmosphere, the more turbulent it becomes. You can make those predictions if you were just simply to carry out the trend. Unfortunately, some of the radiation that we've looked at is not just gradually trending, but actually accelerating. So this is actual. So notice how the solar minimum, solar maximums, notice how they run opposite the neutrons. When we have solar maximum, we have more energy. Solar minimum, we have less energy. Some energies on the sun aren't doing that now, which is why you see an increase in that solar minimum value. Because some of those wavelengths are actually getting stronger even during solar minimum. But again, what we have here, not talking about particles, not talking about neutrons, we're talking about radiation. We have a failure to return to our normal baselines. So that signifies an increase, a major increase. So you can look at this in 2001 and say, if that trend continues, I see animal die-offs, plankton blooms, algae blooms. So you go to another graph and you look at the middle line, which is our sea surface temperature, is more reliable indicator of climate than the air temperature. And you see, while the sunspots are diminishing, the blue line is going in the opposite direction. So whoever came up with the fact that sunspots create ice ages hasn't seen this graph. That's just the bottom line. But generally, if you look at the previous years, you can see that solar maximum, we had bumps in the sea surface temperature. Okay, so they are related, but so something has changed. Something has changed. Sunspots used to indicate climate, but no longer. Now, to hide what the real culprit is, they came up with carbon dioxide, and maybe it was a good theory at the time. But now we see that methane is far greater threat, and now we're not talking too much about the methane, are we? You don't hear too much about that during these heated climate debates. So then we just go to another instrument, and this is total solar irradiance, and this, if you notice, there's a failure to return to baseline, but also telling. This is really telling. This goes back to 2003, so this must be source satellites that were measuring the sun. Notice 1361 is the average. Watts per meter squared. This spikes in this last solar maximum, even though we were told the sunspots are down and we're not having a maximum. You look at the radiation that came off the sun during solar maximum, and you go back 11 years, because 11-year cycle is how you determine your solar cycle, and you can see that would take you back to 2014, 2015, 2006, 2003, 2004, 2005, and that solar maximum is far less. And funny how nobody made that observation. So if they talk about a 0.05% per decade, doesn't sound like a lot. But look, if you have just a single watt per meter square increase in your total irradiance, then you're talking about a 74 trillion watt increase for the planet Earth. And so you could, based upon the trends I just showed you, you could predict this. Look at our land temperatures, 15 degrees above average. Now, we were hearing warnings from warming alarmists about raising the temperature 2 and 3 degrees. Well, look at your ground temperature, you guys. It's 15 degrees above average. I think we're there, aren't we? Wouldn't you say? Am I wrong? Ocean heat content just going up. And part of that is because we're actually have warming down at the lower thermal climes. At 3,000 to 4,000 feet of water getting warmer from what's happening on the surface doesn't make much sense. And of course, when you see all the volcanism on land that's happening, you can just imagine what's going on underneath the water at 5,000, 6,000 feet of water. So, but you can look at all of that and predict all of this. You can predict everything that we predict. Just trend it out. 2004, you see this graph? Hurricane intensity, sea surface temperatures. Well, no wonder why we've had 2 of the largest hurricanes, highest wind speeds ever seen in the Pacific Ocean, just within the last 5 years. So you could have predicted that and looked like Nostradamus. Why? Because you looked at the instruments. So this binary twin that's creating all this havoc, and that's not a theory. I'll prove it. It's not a theory. This is a science magazine. It shows all 3 space probes sent out in various directions, and it shows them triangulating the distance to 2 outer objects way out there. Those objects, you can zoom in here, see if you can read. One of those is called a dead star. And the other one, that's the one at the very top. And the other one, in closer, don't fall out of your chair, the encyclopedia, and a real encyclopedia, calls it the 10th planet at 4.7 billion miles. See, we didn't know that one of those, a brown dwarf, the dead star, we didn't know it was going to come into our solar system when this was allowed to be circulated. And therefore, it has to be part of our solar system, and it has to leave evidence of itself. You know, if it has a 1,500 or a 3,000 or a 5,000 year cycle, it has to leave evidence. You can't just sneak in and sneak out. We'd have to have cyclical extinctions. Oh, wait a minute. We do have cyclical extinctions. But it would leave remnants of itself and hybrids, you know, from the collision. When you take peanut butter and chocolate and you mash it together, you get a Reese's candy bar. Okay, but when you take a brown dwarf and a huge, massive, icy, rocky planet and you crash them into one another, you get comet belt and you get an asteroid belt. And some of those are hybrid objects. You get a little bit of peanut butter and a little bit of chocolate, and you create comets. And so the evidence is there, and they're talking about it more and more, and there's a disclosure, Planet 9. You know, they need to come out and just say binary twin. But it's a fragment. It's a small thing compared to most brown dwarfs. Thank goodness. But all of the comets called the Jupiter group family, the Jupiter family comets, there's something you should know about them. Okay, you can see dozens and dozens of comets, right? You should know they all cross the similar, almost the exact same spot in the solar system. They all cross. They all share a common point. And I don't call it a common point. I can call it an origin point, a place where they were created. That's where they were born. And you look at where they cross, you map it out, you draw it out with a pencil and a little compass, and guess what? It's right around the asteroid belt. Imagine that. And there's a lot of them. And these are periodic comets, and more we're seeing periodic comets. But the orbit of Jupiter you can see out there, and remember that Jupiter has just picked up a bunch of new moons, traveling in the opposite direction of all the moons that we previously knew from our favorite planet in the sky. Now, you're looking down on this. I would tell you it was the asteroid belt, and you would believe me. This is a computer model of all the objects that are orbiting our solar system, but at the Kuiper belt. And when you get that flat angle, if you go back and look, there's groups. There's groups. And that could only mean that they were formed by collision. They're not just there randomly for millions of years. They really aren't uniform. There's clusters of objects. Guess what that means? Collision. So the collision theory of Earth origin is gaining acceptance. And we came under heavy, we had a documentary about the origins of Earth coming from a collision. And we received huge criticism for that documentary, 45-minute documentary. So now this is our asteroid belt. This is where the collision, one of the collisions occurred. And Sure looks like there was collisions in the Kuiper belt and collisions where the asteroid belt is now. And it's amazing how many objects they actually have tracked and plotted. And notice they seem a little more uniform, but the closer you get into the sun, the faster they orbit, which is true for anything orbiting the sun. The closer you get to the sun, the faster you shall travel. But notice look at the grouping, though, of these particular objects. These aren't comets, these are asteroids, and that's Jupiter way out there. I'm circling around. And you have to wonder, what the heck is going on? And, people say that Jupiter's part of the Nibiru system. We all may be part of the Nibiru system. Jupiter may have been that large icy planet, or Uranus may have been that large icy planet. Saturn may have been, who knows? But there was more than one collision. It was written about in ancient stone, very specific details on how Earth was created and Venus. And guess what? All of that, biggest computer models of the world, all the satellites, all the data put together, kind of support what was found on that clay tablet. Again, this shows you a flat edge clustering of the asteroid belt. And amazing is just how many there are. And when you look at, no matter what kind of abstract mapping, you get an idea that there's families of objects. Birds of a feather were traveling together. So yes, there is a binary twin to our sun. It may have other planets that are Earth-like. No, we're not being told everything that NASA knows. But can you imagine something even larger than Jupiter, a massive icy planet, cue-balling off an inbound, high-speed, high-spinning brown dwarf fragment? And you would create asteroid belts. You would have periodic comet bombardment. Oh, and in the news, also, I just wanted to share with you, the unmanned SpaceX space shuttle landed after, I think it was 277 days, setting a record in space, unmanned. I wonder what he was doing up there for all that time. Probably enjoying the peace and quiet. Congratulations, SpaceX. So also we were talking about how when you go through all of these cosmic rays created by our binary twin that's getting closer, and the cosmic rays get dense, well, guess what? Venus doesn't have a magnetosphere. It has an atmosphere, but no magnetosphere. So those particles interact. And there's a V-shaped wave on Venus that stalled out every time. It stalls out every time Venus goes by there. It wasn't just one freak December. I tell you what, there's two jet streams on Venus. They're kind of tilted, and that gave us the other cloud layers shaped a V. Well, those get changed, and they stall out. That V shape stalls out because of resistance brought to you by a brown dwarf, our binary twin. So we're thinking we're going to pass between it. It's a theory, and since 2017, we haven't been so cocky and confident about predictions because this thing was moving so fast, and it was hard to predict what was going to happen. So far, all the data, all the information, every single shred of it kind of makes this thing adhere to a orbital model put forth by a chief of naval astronomer. So what we're looking for is an increase in earthquakes. There is an increase in smaller earthquakes on the daily basis. The blue ones, the blue circles are, only a 24-hour measurement, and the yellow ones are within the last week. But I'll tell you what, whenever we came in alignment with the sun and this brown dwarf that we have been tracking for quite some time, the mid-Atlantic ridge always shifts. The entire ridge shifts over about a period of 3 weeks. So, you could just look at the mid-Atlantic ridge and forget about the 6 pointers and still use that as evidence of a tidal influence of something. So, but time will tell if we're right or wrong. But ultimately, it comes back to this: so what? We're going to have an extinction. We're going to all die. Whatever. Why even go there? Why talk about it? Why not just live your life? But the problem is nobody knows how this plays out. I think the Bible kind of gives us a hint, because this kind of cycle is described about before, not just in the Bible, but in other references. There has been major floods. There has been bombardments from the sky. In recorded history, there has been pole shifts in recorded history. There's been fire from the sky. So, in recorded history, and the Bible records it too. So nobody knows exactly how it plays out. And each time this brown dwarf comes around, it's a little bit smaller. It loses a little bit of itself. It leaves a little bit of itself in our solar system every time it comes through. And so nobody knows how this is going to play out. And therefore, to be casual about it may be irresponsible. And that's all I got to say. Until next time, you should all, have a 3-day pack in your car.